All right, guys, we're going to do the very last part of the properties of exponents notes. So I need you to turn to numbers 4 and 5 on those notes I gave you yesterday, okay? So the notes look like this. You did 1, power 0, 2, the negative power, and 3, multiplying powers with like bases. I need you to go to 4 because we're going to do 4 and 5 today. All right, so when dividing powers with like bases, in other words, your bases got to be the same. What you want to do is keep one base, and instead of add the exponents, you want to subtract the exponents. So I'm going to go back to something. So up here on this one, when you multiply powers with like bases, you still kept a base, one base, but you added the exponent. So let me tell you something. See, multiplication and addition go together. M-A. Multiplication and addition go together. But it's just the opposite down here. Division and subtraction go together. Okay? So if your multiplying powers are the same base, you add the exponents after you keep one of the bases. But if you're dividing powers with the same base, you subtract. Okay? Maybe that will help you. So you're going to keep one base. Look at A. I have x to the 5th divided by, that bar means divide, x to the 2nd. Well, you keep one base because you got a base here, and you got a base x here. I don't need both of those bases. I just need to keep one base, right? One base x, and I'm going to subtract the exponent. Subtract. Make sure you subtract from top to bottom. And I need you to do me one other favor. If you subtract the negative, put it in parentheses. If you subtract the negative exponent, put it in parentheses for me. Okay? But see, your exponent here is 5 and your exponent here is 2. You're not subtracting a negative. You're just subtracting 2. 2 is positive. So don't have to worry about parentheses. Let's just do 5 minus 2 is 3. So again, let me just go back through this one more time. You got a base x on the top and a base x on the bottom. So you just write one base and you subtract the exponents from top to bottom. So put the 5 first, subtract the bottom, which is 2. 5 minus 2 is 3. That's all you do. Now, if you look at B, somebody's going to say, oh, I got a negative exponent on both of those ends. Let me flip them. No, you only flip when you have one of each base. Okay? If you got one of each base and you got a negative left on it. So the reason you don't want to flip here, sorry guys, is because you got a base N on the top and a base N on the bottom. I don't need to have two base N's and try to flip the exponents automatically. I need to have one base N. And if the exponent is still negative after I write one base N, then I'll flip it. So let's write one base N. And you're going to subtract the exponents. And I'm going to have to erase this stuff. But hopefully you're pausing the video and writing this down. Start from top and subtract what's on the bottom. Well, what's on the bottom is a negative. But I told you if you subtract the negative to put that number inside of parentheses. So since I'm subtracting a negative 7, I'm going to put it in parentheses. That helps me to see that I got a double negative. Okay? So now it's actually negative 5 plus 7, which equals 2. So it's n to the second power when you finish. And there's no need to flip the n because your 2 is a positive exponent. Again, don't try to flip anything when you got multiple representations of the same base. You got more than one of the same base, okay? Now, if I would have ended up with a negative in the end, fine, flip it after I get one base. All right, C is a little different. You have a coefficient of 4 and a coefficient of 8. Remember, coefficients are numbers in front of the variables. But you're going to look at this whole thing as a fraction. So you're going to take 4/8 and you are going to simplify it. Basically, I need you to simplify the fraction 4/8 because 4/8 is acting as a fraction. So to simplify 4/8, it ends up being 1/2. Some people will just put 4/8 is 2 instead of 1/2. But that's assuming that the 8 is on the top. When we see that in the actual problem, the 8's on the bottom. This is 2. But 4/8 is 1/2, guys. So don't mess up on that. You don't get a whole number unless your top number is bigger than the bottom. And 4 is definitely not bigger than 8. So I'm going to write just 1/2. And I already have a bar. I just extend that bar. I already have a division bar because in 1/2 you got the bar in the middle. All right, so when you extend that bar and you have two base A's, you got base A right here and base A right there. Once you write that one base A, always write that one base. Always write that one base on the top if you're combining them, on the top of the bar. Don't do something like this. Don't do that, okay? So when you get ready to combine them and make one base, write that one base on top of the bar. Okay, one base on top of the bar. And then you combine your exponents. So you're going to take 12 and subtract the -5. Okay, now be careful because you have 12 minus a negative. So that minus a negative, that -5 goes in parentheses. So basically this is 12 plus 5, which is 17. So that's your answer. Now, some people don't like putting that 1 in front of the a to the 17th. So they write it as an understood 1 and just write a to the 17th over 2. More than likely, you're going to see that. But you can see it written like C is with the 1/2. Okay, in the problem. You can see it written like this. All right, so let's take a look at D. I'm going to take 3/9 and simplify it. 3/9. I'm going to divide them both by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. So I see I get 1/3. But extend that bar because your X is going to have to go here, and your Y, that one base of Y is also going to have to go on top. Remember, if you write that one base, write them on top of the bar. And then subtract your exponents. So I'm going to take my exponent for X, and I'm going to say 4 minus, 2's negative, so put it inside of parentheses. So basically I end with 4 plus 2, which is 6. So it's going to be X to the 6. Now what's going to be above the Y? Well, let's take the exponents. So here you have a Y of 5 minus, not a Y of 5, an exponent of 5 minus an exponent of 8. Well, that ends up being -3. Okay, this is not what, sorry. This is not in simplest form yet. The reason why it's not in simplest form is because your remaining base of Y has a negative exponent. Okay? So although you achieved getting one base Y and one base X, and you simplified 3/9 to 1/3, you got a negative exponent on Y. So this is the one you're going to have to flip. Remember, you don't flip them into the very end. I don't want you going back and thinking, well, I should have flipped this one, that end, and I should have flipped this end. You only flip it once you end up with one of those bases, just one base. Okay? So since I only have one base Y and it has a negative exponent, I can go ahead and flip that. So that's going to be 1x to the 6. Your 3 stays, but that Y is going to flip to the bottom, and -3 is going to become +3. But lots of times you won't see this 1. You'll just see x to the 6 over 3y to the 3rd. I will take either one of these, okay? If you're confused on something, stop the video and let me know. If you don't know why I flipped the Y, sorry. If you don't know why I flipped that Y, then let me know. All right, let's take a look at 5. 5 is the last property of exponent rule we're going to learn. There's actually another one, but it's much more detailed. I'm not going to cover it during summer school, okay? So 5 is a power of a power. When you have a power of a power, it just means, and pay attention, all it means is that there is an outside exponent. When I say outside, it's an exponent sitting out here outside a set of parentheses. So when you see something set up like this, where you have parentheses and an exponent sitting out here, you're going to apply this rule. You're going to multiply the exponents and just keep the bases the same. You won't have multiple bases, like you won't have like bases. You won't have 2x's or 3x's or 2y's and 3y's. Okay. You won't have multiple bases. You just have one. Like here I already have 1x. Here I already have 1 base x. And I have 1 base y. Okay. But up here, see, I had base x here. I had base x there. I had base y, base y. Oh, I didn't do e. Let me go back and do e. Then I get back down here, okay? I'm so sorry. I'm glad I went back to that. Let's go back to e. It's my fault. All right, so on e, what I want to do is I want to take 18 ninths and simplify it. Well, 18 is bigger than 9, and it's on top. So basically, I'm trying to figure out how many groups of 9 I can get out of 18, which is 2. Now I get the whole number 2 because my top number is bigger. Now, had it been written like this, 9 is smaller than 18. My bigger numbers on the bottom, I'm going to end up with a fraction. Bigger numbers on the bottom, you always end up with a fraction or a decimal. We're not going to be writing them as decimals. We're going to keep them as fractions. Okay? But because in E, 18 is on top and it's bigger, I can end up with a whole number. So I'm going to put the whole number 2. All right? Now, you don't even have a bar to write your x, 1x on top of, your 1y on top of. So what I'm going to do is just put my x. I want 1x. I also want 1y. And I also want 1z. Now, if you got something like 1/3, you got to extend the bar and your variables will go up here, okay? But if you don't end up with a fraction, suppose you end up with the whole number 2 like we did on E, just write your 1x, your 1y, your 1z, or whatever the variables are, write them next to the 2. There is no top and bottom, not right now. All right, so for x, I'm going to take -3 and subtract the exponent on the bottom, which is 5, and with -8. All right, so for y, well, what's the exponent for this y? -5 minus the exponent here. Well, the exponent on the bottom is negative, so I put it inside of parentheses. So I get -5 plus 1, which is -4. And then, of course, z doesn't have anything on the bottom here. It's nothing. So I don't worry about it. I just write this back down. I just write my z back down. So z to the -2nd. Well, you got a lot of stuff that has a negative exponent. So looking at this, I can see that x has a negative exponent, y has a negative exponent, and z has a negative exponent. The only thing that will not flip is the 2, okay? It won't flip. But now this other stuff will. So I'm going to draw a bar because I need a bottom. I need some place for it to flip to. The 2's going to stay put, and the x is going to flip. -8 becomes +8. The y is going to flip. -4 becomes +4. The z is going to flip. -2 becomes +2. Now I'm done. Again, if you don't understand something, let me know. And when you have multiple bases, you have to write one of those bases and then either add or subtract the exponents. Add if you're multiplying, if it's multiplication between those multiple bases. Divide subtract if it's division between those multiple bases. Let's go back to this one. So when there's an outside exponent, I need you to multiply the exponents and keep the bases. Again, I said there will already just be one base. Like here's just 1x. Here's 1y. Okay? 1x, 1y. You won't have multiple bases where you have to add or subtract to try to make one of them. Okay? So basically, we're just going to multiply. Keep the bases the same. So if you look here, I got my 1 base x already. I'll keep my 1 base x. You just keep it. But I multiply the two exponents. 5 times 2 is 10. I'm done. That's all you do. All right, here I got my 1 base x. Got it already. So I come over here and I keep my 1 base x. It's just got one x. But what do I do to get the exponent? Well, I take the outside exponent and I multiply by the exponent for the x. So that's 4 times 2, which is 8. So that's how I got that 8. Then I see I have 1 base y. So over here, I keep a base y. I'm keeping the bases. But how did I get to the exponent of 12? Well, you just take the outside exponent and multiply by the exponent for y. Well, the exponent for y is a 3, and 4 times 3 is 12. And that's all you do. That's it. You're done. Kind of like using the distributive property with the outside exponent. All right, so here I have 2 is acting as a coefficient. Okay, but I'm going to keep it. Okay, it's acting as a coefficient, but I keep it. But I need an exponent for it, okay, because it's got that outside power. It's got that outside exponent of 3. Okay, so what I do is I know that 2 has an imaginary 1, so I'm going to do 3 times the exponent of an imaginary 1, and it gives me 3. So 3 goes there. All right, now I got 1x. I'm going to keep that 1x. You just keep it. Okay? And then now you have to decide how do you get the exponent for that x you kept. Well, you take the outside exponent of 3 and multiply by the exponent on the x, which is 2. 3 times 2 is 6. Then you have a y. Okay? So you're going to keep the y. You just keep it. Again, you're keeping the bases, okay? Keep the bases. All right, but how do you get the exponent for that y? Well, you take your outside, it says multiply the exponents. You take the outside exponent and multiply times the exponent for y. So 3 times 5 is 15. Okay. So basically, it's for every coefficient or base that you keep, you multiply that coefficient or base's exponent by the outside exponent. So again, I multiplied by the exponent of 1 by 3, the exponent of 2 by 3, the exponent of 5 by 3. That's all you do. For every base that you keep, multiply that base's exponent by the outside exponent. Now, if you'll look, I'm going to go ahead and say 2 cubed is 2 times 2 times 2. Keep the x to the 6 and the y to the 15. We'll just bring it down, okay? Let me erase all that. So basically, I changed this to this. I brought this down and brought that down. 2 times 2 is 4, and 4 times 2 is 8. So this ends up being 8x to the 6, y to the 15 when I simplify. Yes, I want you to change 2 to the third to 8 because it's acting as a coefficient. It's sitting in front of some letters. Here I'm going to keep the x, and I'm going to multiply negative 3 times the exponent of x, which is 4. So that gives me negative 12. So I have 1x, but my exponent is negative. So I'm going to flip it. So that's 1 over x, flip it, and negative 12 becomes positive 12. That's your answer. Okay, I don't have that much left. All right, you're going to keep 1x, and you're going to multiply the 5 by the exponent of x. So 5 times 4 is 20. All right, you're going to keep 1y, and you're going to take the exponent of 5 and multiply by the exponent of y. Well, what is the exponent of y? Well, it's an understood 1. So 5 times 1 is 5. I'm done. That's all you do. All right, on F, you're going to keep the base of x, but I'm going to take the exponent of negative 2 and multiply it by the exponent of x. So negative 2 times 4 is negative 8. And keep a y, but let's multiply the outside exponent, negative 2, times your exponent for y. Negative 2 times negative 3 is positive 6. This is the one I'm going to have to flip because it has a negative exponent. Okay, so I'm going to create a top and a bottom by drawing a bar. Keep that y to the 6 on top, and I'm going to flip x and make negative 8 positive 8. And I'm done. Okay, let's take a look at the last 3. So let's look at G. Okay, I'm going to keep the negative 3. I'll take the outside exponent and multiply by the exponent of negative 3, which is an understood 1. So I'll get 3. Keep the x. Take 3 and multiply it by 12. It's 36. Keep the y. Take the 3 and multiply it by 5, which is 15. Keep the z. Take the 3 and multiply by negative 4, which is negative 12. Now, because this sits in front of some letters, it's acting as a coefficient. I need to multiply it out as a regular number. So negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3 is 9. And 9 times negative 3 ends up being negative 27. So I have negative 27, x to the 36, y to the 15, and z to the negative 12. But I have a problem. One little problem. You see this? That z still has a negative exponent, so I need to flip it. So I'm going to create a bar and keep the negative 27 on the top, the x to the 36 on the top, the y to the 15 on the top. But this has to be flipped, so it goes to the bottom, and negative 12 then becomes positive 12. And that's all you do for that. All right, again, if you're confused on something, please pause the video so I can help you. Or go back and rewind it again, see if you pick it up. All right, so I'm going to keep the negative 3. Keep this negative 3. And multiply the 2 by the negative 3's exponent. Well, I don't see an exponent for the negative 3, but it's an understood 1. 2 times 1 is 2. Now I'm going to keep the x. And we'll multiply 2, the outside exponent, by the exponent for x. Well, I don't see an exponent for x, so I know it's a 1. 2 times 1 is 2 again. Now I'm going to keep the y. 2 times 3 is 6. This is acting as a coefficient because it's in front of some letters, so I want to multiply it out. So basically, it's negative 3 times negative 3, which is positive 9. I'm going to write it down here, guys. It's positive 9, so I get 9. And then just bring this down. X to the second, y to the 6. That's all it is. Okay, let's look at this last one. I'm going to keep the 4. And we're going to take negative 2. Let me erase this so it's not so bunched up. Make sure you're pausing the video and taking notes. I'm going to keep the 4, kept it. I'm going to take negative 2 and multiply by the exponent of 4, which is 1. I understood 1, so I get negative 2. Then I'm going to keep the x. I'm going to take negative 2, the outside exponent, multiply by the exponent for x. Negative 2 times negative 3 is positive 6. Keep the y. Take negative 2 and multiply by the exponent of y. Well, what is the exponent of y? It's an imaginary 1. So negative 2 times 1 is negative 2. Then I'm going to keep the z. And I'm going to multiply negative 2 times the exponent of z, which is a positive 4. Well, negative 2 times 4 is negative 8. Now I just need to go through and fix everything that has a negative exponent. So let's fix it. This has to flip because it has an exponent of negative 2. X doesn't. It has a positive 6. Y has to flip. It also has an exponent of a negative exponent. And also Z has to flip because it also has a negative exponent. So the only thing that's going to stay put is x to the 6th power. So I'm going to draw a bar to have a top and a bottom so I can flip stuff. That x to the 6th stays put. This 4 flips to the bottom because this exponent was negative, and negative 2 will become positive 2. Y flips to the bottom, and negative 2 becomes positive 2. Z flips to the bottom, and negative 8 becomes positive 8. I want to fix one more thing because this 4 is acting as a coefficient. I can multiply it out. 4 squared is 4 times 4, which is 16. So I can write this as x to the 6th over 16, y to the 2nd, z to the 8th power. Now somebody's going to ask, well, why didn't I multiply the 4's right here? Because you can't write out negative 2 4's. If I said, okay, you all, can you write down negative 2 4's? You would look at me like I'm crazy. But if I said, can you write down 2 4's? You write down 2 4's. 1, 2. There you go. But you can't write down negative amount of anything. Okay? So before you can multiply this out, I need you to get rid of the negative. That's why we flip it first. All right, if you have questions, again, make sure you pause the video and call me to your desk before you work on your practice. Thank you.